Good morning, class. We are looking at polar form of a complex numbers. Polar form, also known as a complex plane de Moivre's theorem. The objective for the section is to plot points in the complex plane, convert the complex number between rectangular and polar form, find product and quotient of complex numbers, and use de Moivre's theorem, find complex roots. So a quick reminder of basic trig identities. We have seen many identities, such as sum, difference, double angle, half angle, you name it. Then as far as polar coordinates are concerned, a quick reminder, here's a polar axis similar to an x-axis. A point has coordinates x and y in a rectangular coordinate system, r, comma, theta in polar. Theta is the angle with the positive side of the x-axis or the polar axis, and r is the distance from the pole. Here's some graphs we discussed. If theta is a constant, y equals tan alpha times x will be a line going through the origin. R equals A becomes a silicon centered at 0, 0 with the radius A. R cosine theta equals A becomes x equals a vertical line. R sine theta equals B becomes a y equals B, a horizontal line. When we have 2a or minus 2a, cosine theta or sine theta, all of them result in a circle if it involves cosine. It's along the x-axis. If it involves sine, it's along the y-axis. And we have other equations, a cardioid, lemma without inner loop, with the inner loop. And also we discussed roses. So this is the synopsis of what we have done. And now the summary of the complex plane de Moivre's theorem is as follows. A complex number is in the form of z equals x plus yi, where x and y are real numbers and I is the square root of -1. I want to remind you that we have studied this concept of a plus bi. I hope you remember that. A complex number where I is equal to square root of -1. It is absolutely the same. But now we're going to represent it with x and yi. The magnitude, or it's called the modulus of z, is the distance from the origin to the point x comma y, and it's calculated as something you've seen, square root of x squared plus y squared equals r. Another way of looking at it is the square root of z times z bar. Z bar is the complex conjugate of z. So x plus yi becomes x minus yi. So that's the relationship between z and z bar. I hope you remember complex conjugates. We used to say if you have a plus b, the conjugate is a minus b. If you have a plus bi, the complex conjugate is a minus bi. So therefore, if you multiply a plus b times a minus b, you recall it's a squared minus b squared. However, if we multiply a plus bi times a minus bi, we get a squared minus I squared b squared, which is a squared plus b squared. Also, I is square root of -1. I squared is -1. I cubed, which is I squared times I is negative I to the power of 4, which is I squared to the second power is positive 1. So that means powers of I can be reduced, and if it's 4 becomes 1. This is just to refresh your memory about complex numbers and what we know about them from algebra. X equals r cosine theta, y equals r sine theta. We remember it from polar form. Complex numbers in polar form. Z is x plus y, r equals r cosine theta, o plus I, r sine theta. Now, the synopsis of that, okay, a short version of this, r cis theta. C stands for cosine, I stands for, say, good old I, and S stands for sine theta. So r cis theta means this. So let's take a look at the graph. So we have a rectangular grid, and this x-axis is also the polar axis. A point with coordinates x comma y represented with r comma theta. So this point, x comma y, or r comma theta. And this distance r is called the modulus or magnitude, which is the good old r, or square root of x squared plus y squared. Z is x plus y I, r times cosine theta plus I sine theta. Another notation would be r cis theta. R is positive, theta is between 0 and 2 pi. Another notation is r e to the power of I theta, which is the Euler equation. R squared again is x squared plus y squared. Tan theta is y over x, and you should always figure out the value based on the quadrant. If you want to multiply two numbers, complex numbers that are given in a polar format, multiply their modulus, r1 times r2, and then cosine of, add up the arguments, plus I sine of, add up the arguments. If you want to divide that, r1 divided by r2 and subtract the arguments. The Morse theorem says if you want to raise it to the power, so raise r to the power of n and then multiply the theta by n. This is in case n is larger than or equal to 1. And if you want to take a root where n is larger than or equal to 2, there are n distinct complex n. You take an nth root of the number, so that's clear. And the rest of them, again, cis because it's a shorthand notation, remember. You divide theta 0 by n, and then you add 2k pi divided by n, and you let k be 0, 1, 2, all the way to n minus 1. For example, you want the fourth root, you let k be 0, 1, 2, all the way to 3. All right, so that's a good synopsis. Let's get us started. For example, we want to plot and write complex number z equals square root of 3 minus I. So first, let me give you a synopsis of some examples, just as we've seen before. If I'm interested in a plus bi in general, I go a units along the x-axis, which is now the real axis, and I'm going to go b units along the y-axis, we are going to call it imaginary axis, or I, how many i's in essence. So if I want a plus bi, as I said, a and b. Now, if I want 3 plus 2i, I'll go 3 along the x-axis, 2 along the y-axis. Now we're going to call it, again, imaginary, so that's 3 plus 2i. Negative 4 plus 3i. 4 to the left, 3 up, minus 4 plus 3i. Minus 2, minus 3i. 2 to the left, 3 down. So just as you would represent a point in a rectangular grid, very simple. And again, I have the information here. So let us find the point. It has square root of 3 minus I. So we go, square root of 3 is about 1.7 roughly. So you go about 1.7 along the x-axis in a positive direction. You go down. This is minus I. You go down by 1 unit. So it's roughly here. So we locate that. Now we want to write it in polar form, which means I need to find r. R squared is x squared plus y squared. So r is square root of x squared plus y squared. So x is square root of 3 and y is negative 1. This becomes 3. This becomes 1. So we have square root of 4, which is 2. So we found r. We need to find the theta. So if we connect this, we want to find the theta. In essence, you can. You can see what we are looking for. Tangent theta is y over x. And it's negative square root of 3 over 3. Remember, with square root of 3 over 3, you get pi over 6. When it's minus, then we get in this quadrant minus pi over 6, minus pi over 6, or 11 pi over 6. Remember, it's the third quadrant. If you want to go with the positive. And if the negative is fine, again, this is the same as minus pi over 6. So r cis theta. So we are going to write r is a 2 cis 11 pi over 6, which means cosine of 11 pi over 6 plus sine of 11 pi over 6. By the way, if you evaluate the cosine and sine and you multiply by 2, you come up with the answer. This is I here missing, so I wanted to write that for you. So we definitely need the I there. Or simply put, you can write 2 cis 11 pi over 6. Either way is fine. All right. Let's go to the next page. Plotting a point in the complex plane and converting from polar to rectangular form. So if we want to plot this first, so we have a rectangular grid and we start with the theta angle 30 degrees. So we go 30 degrees and we go 1 and 2 tick marks. So we make up a 30-degree angle and we go 1 and 2 tick marks. That's R. Now, if you want to go to a rectangular format, just replace the cosine of 30 degrees with square root of 3 over 2. It's a common arc. Sine with 1/2. So I times 1/2 or 1/2 I. Now, if you distribute number 2, this becomes square root of 3. This becomes simply I. So square root of 3 plus I would be the rectangular form of a complex number. Z equals 3 times cosine of 3 power 2 plus I sine of 3 power 2. Obviously, you have to just evaluate this, needless to say. R is number 3 and theta is 3 power 2. And as you know, cosine of 3 power 2 is 0. Sine is negative 1. So 3 times I times negative 1 gives us negative 3I as the final answer. We want to find the product and quotient of complex numbers in polar form, where z sub 1 is given r1 cosine theta 1 plus I sine theta 1, and z sub 2 is r2 cosine of theta 2, I sine of theta 2. That represents two different numbers. The product, you multiply the r's and then you add up the arguments. The division, you divide the r's and you subtract the second argument, the bottom argument from the top argument. I have left the proof of this one at the end of the PowerPoint, so you can look at it. Let's quickly look at one of the proofs, the first one. So we are going to multiply. So I'm looking at the multiplication. We are going to multiply Z1 by Z2, where Z1 is the first one. Look at this one. And Z2 is the second one. So to multiply these two, we have to distribute. First of all, it's R1 times R2. We put it out here. Then cosine of theta 1 times cosine of theta 2. So we get cosine of theta 1 times cosine of theta 2. Then we get, we are foiling, cosine of theta 1 times I sine theta 2. Then we said we get I sine theta 1 times cosine theta 2. And then we get I sine theta 1 times I sine theta 2. So let's see what it looks like. This is the first one. Cosine theta 1, cosine theta 2. Here's the second one. Cosine theta 1 times sine theta 2 and times I put the I in front. These two, again, we put the I in front, sine theta 1, cosine theta 2, and these two, I sine theta 1 and I sine theta 2 gives us I squared sine theta 1, theta 2. As you know, I squared changes to -1, or simply minus sine theta 1 sine theta 2. This one has sine theta 2. Okay. Now, let's put these two together. So we say R1, R2 times this, cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2. And let's put these two together. And when we put these two together, we take the I out as well. So take a look at what happens. We have cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2. And this one, we take the I out. We can put this one first because I want to show you the order. Sine theta 1, cosine theta 2. And I put this one second, cosine theta 1, sine theta 2, because you should recognize this is cosine of theta 1 plus theta 2. This is sine of theta 1 plus theta 2, because remember that sine of alpha plus beta was sine alpha cosine beta plus cosine alpha sine beta. So I hope you recognize that. That's the proof. Again, I have the proof for this one at the end. You just do the same thing. You set this one up in the numerator, this one in the denominator, and you multiply by the complex conjugate of this, and you will get to the proof. Let's use this. Z is given as 3 cis 20 degrees and W as 5 cis 100 degrees, and we want to get their product first. So R1, R2, cis theta 1 plus theta 2, which means 3 times 5 cis 20 plus 100. 3 times 5 cis 20 plus 100. Again, cis means cosine and then I sine. So this is 15 cis 120 degrees. So we found the product in a complex form. Now let's go with the division. We're going to go with the division, everybody. R1 over R2. That means 3 over 5. And then cis theta 1 minus theta 2. That means 20 minus 100. So this 3/5 remains. It's an exact answer. And 20 minus 100 gives us negative 80 degrees. And that's fine. If we want a positive value, then we add 2 pi, or in this case, 360 degrees, which gives us 3/5 cis 280 degrees, again, because we want the positive value for theta. Add 2 pi, since it's in degrees, 360 degrees. We want to use the Moore's theorem to write this 2 times cosine of 15 degrees plus I sine 15 degrees to the 4th power in standard form. So what we are going to do is to use the polar form to get to the answer, and then we convert it. So first, if you want to raise something to a power, a complex number, it is easier to use the polar form and then convert it. So according to the Moore's theorem, if you want to take this to the power of n, then it's r to the power of n. Remember, we want it to the power of 4. So 2 to the power of 4, 2 to the power of 4. And then cosine of n theta, n is 4. So cosine of 4 times 15 plus I sine of 4 times 15, according to this. All right, so we want to raise this to the 4th power. So 2 to the power of 4, and then cosine of 4 times 15 plus I sine of 4 times 15. So 2 to the power of 4 is 16. 4 times 15 is 60 degrees. So that would be the answer in polar form. And to change this to standard form, or a plus bi, or x plus yi, cosine of 60, you know it to be 1/2. Sine of 60, square root of 3/2. So when we distribute 16 times 1/2 becomes 8. This one becomes plus 8 square root of 3i. By the way, sometimes they put the I in between because they want to make sure you recognize this has to be outside the radical sign. So we don't want to mix them up. It's extremely important. Z equals 1 minus I, and we want to raise it to the power of 10. In order to do that, this is a rectangular form. That means I got to multiply 1 minus I by itself 10 times. We don't want to do that. It takes a long time. An easy way is to change this to polar form r cis theta first, and then use De Moivre's theorem. So let's do that. First and foremost, we need to find this. So the modulus of z, or r, is x squared plus y squared, which is 1 squared plus negative 1 squared. So modulus of z, or the magnitude, or r, they all mean the same thing. This is 1, this is 1, so it's square root of 2. Tan theta is y over x. That means negative 1 over 1, which is negative 1. It's a common r, minus pi over 4. And you can keep it as that if you insist to go to positive, because we want to raise it to the power of 10. It's easier to keep it as negative. But remember, if you want to change this to a positive, you add 2 pi. It puts you in the same quadrant, which is the fourth quadrant. And we have 7 pi over 4. All right, let's go with z equals r cis theta and write this. That means square root of 2 times cis negative pi over 4. Again, it's actually easier to write. Let me write that. So you can keep it that way and then change it at the end. You can just write it as square root of 2 cis negative pi over 4 and deal with that. So you don't have to write the whole thing, but I wanted to show you if you write the whole thing. Either way is fine. Now, we're going to raise to the power of 10. This. We're going to raise this to the power of 10, and we're going to multiply this one by 10, right? So z to the power of 10, we are going to raise r to the power of 10, and we're going to multiply the argument of cosine and sine by 10. So I hope you realize when you take square root of 2 to the power of 10, that means the same as 2 to the power of 5, right? And if you multiply this one, you get minus 10 pi over 4, or minus 5 pi over 2. In other words, this is 2. This is 5, the same thing for the second piece. Now, 2 to the power of 5 is 32. And since it's minus 5 pi over 2, if I take away 2 pi, in other words, I add 2 pi, becomes minus pi over 2. You don't have to do that because you can even evaluate it right here. But if I add 2 pi, makes no difference, gives you the same location. So it's cosine of minus pi over 2 plus I sine of minus pi over 2. As you know, cosine of negative pi over 2 is 0. Sine of negative pi over 2, or 3 pi over 2, is negative 1. So we have 32 times I times negative 1, making it negative 32I, which means 1 minus I to the power of 10 is minus 32I. Instead of having to multiply this by itself 10 times, this is a faster way of coming up with the answer. In essence, we want to raise this to the power of 6, right? The expression in standard form of a plus bi. So we want to raise this to the power of 6, which means we're going to use this formula. So this gets raised to the power of 6, and this gets multiplied by 6. I'm going to write it r to the power of 6 cosine of 6 theta plus I sine of 6 theta. So we're going to write square root of 3 to the power of 6. And 6 times 10, same thing, 6 times 10. This one, of course, is 3 cubed, which is 27. And this is, of course, 60 degrees. So 27 cosine of 60 plus I sine of 60. And as you know, cosine of 60 is 1/2, and sine of 60 is square root of 3 over 2. And therefore, the final answer is 27 halves plus 27 square root of 3 over 2I. So we have this, which is in polar form, now in standard form or rectangular form. Complex roots. Let W be R cosine theta 0 plus I sine theta 0, and n is larger than or equal to 2. This has n distinct complex roots. Z sub k is the nth root of R, and the way you find it, you divide theta 0 by n and you add 2k pi over n. Remember, k is an integer. Same thing for this one. In other words, this will be the new argument. And you let k be 0, 1, 2, and minus 1. This is finding complex roots in this manner. So find complex cube roots of -4. So first and foremost, you have to represent this in the form of R cis theta. And it is important to know, if you have a positive number, is R cis 0. A positive number is R cis 0 because this side is positive and this side is pi. So a negative number is R cis pi. So if I have, for example, 4, it's 4 cis 0, but if I have -4, is negative, is 4 cis pi. So that's an example. All right, I'm going to, instead of going through the process of finding R and theta, I'm showing you in general if the number is positive or negative. It's along the positive x-axis or the negative x-axis. So for negative, we go with pi. And so let's clean this up. Therefore, this is 4 cis 180 degrees or pi. Now, what we are interested in is finding the cube root. Therefore, we want 3 of those. Every number has, if you want to get the number of roots, it has that many complex roots. For example, you know cube root of 1 to be 1, but there are 2 more. The other 2 are complex, and that's the idea. So let's finish this off by writing this formula. Z sub k is now the nth root of R. That means the third root, because we want the cube root. The third root of this number, which is 4. And then we write cosine of theta 0 over n, which is 180. It's easier to use degrees. You can use pi, but degrees are a lot easier in this case. If you went with pi, there is nothing wrong with that. So 180 degrees divided by 3. And instead of 2k pi, obviously, we're going to use 360 degrees. So if we go with degrees, then this is 360 degrees. All right, so cosine of 180 divided by 3 plus 360k times 3, again, 2 pi times k. Remember, k is an integer. Instead of 2 pi, you go with 360. And the same thing happens for the argument of sine. So let's divide this by 3. And by the way, you can keep it the same because remember, this you need a calculator. It's an irrational number. So let's keep it as cube root of 4. Cosine of this is 60 degrees. And if you divide 360 by 3, it's 120 degrees times k. Now, what is k? K goes from 0 all the way to n minus 1. Since we want the third root, then k can be 0, 1, 2. Now, notice what's going to happen. If I replace this with 0, the answer is cube root of 4 cosine of 60 degrees plus I sine of 60 degrees. If I replace it with 1, 60 and 120 is 180 degrees. So cube root of 4 cosine of 180 degrees plus I sine of 180 degrees. Let's do 2. 2 times 120 is 240 and 60, 300. Cube root of 4 cosine of 300 degrees plus I sine of 300 degrees. So those are the three by using 0, 1, and 2. Zero for this one, 2 for this one, 1 for this one. So let's explain what this means. I want to make sure we understand this a little bit further. So that means all cube roots, all of them, have a magnitude of cube root of 4. And as I mentioned, you can always put it into a calculator and come up with the answer. So that's the magnitude. And that's about 1.5, 1.6. So this is close to 1.6. So that's the magnitude. The arguments are 60, 180, and 300, which means they're equally spaced at 360 degrees divided by 3 or 120 degrees. So what does it mean? You can come up with the circle centered at the pole or the origin with the radius of cube root of 4. Again, cube root of 4, as I said, is close to 1.6 roughly. So all 3 points are equally spaced on a circle of x squared plus y squared equals cube root of 4 to the second power. And again, the radius is cube root of 4. This radius is about 1.6 roughly. So cube root of 4, each one is cube root of 4, right? Those radius. And this is at 60 degrees. Now spaced at 120, if you add 120, you end up with 180. And another 120, you end up at 300. That's the meaning of it. Now, I explained about positive numbers, where you write them as the number cis 0, if you remember. So in essence, whenever you're done with this, this is 0. And if you choose k to be 0, this ends up being 0. For example, number 1 is 1 cis 0. And remember, cube root of 1 is 1, but 1 has 3 cube roots. 2 of them are complex. So 1 is along the x-axis or a polar axis, and that's 1 plus 0i. Okay, it's the unit circle in essence. So, and those are negative 1/2 and square root of 3 over 2i, negative 1/2 minus square root of 3 over 2i. It's hard to see that, but they are spaced again at the same 120 degrees, but it starts at 0. This one starts at 60 degrees because it was negative, but the spacing of 120 degrees is the same for both of it. Why is it 120 degrees? N equals 3, so you have to divide 360 by 3. So they space. So if you're looking for the cube root of any number, they're spaced at 360 divided by 3, which is 120 degrees. If you want 4 of them, you have to divide by 4. That means 90-degree difference. Okay. We want to plot this number, 3 minus 4i, in the complex plane and write it in polar form. So 3 to the right, 4 down, 3 to the right and 4 down. In essence, you can say 3 and negative 4 if we were thinking of just basic x comma 1. And so we want to write it, and they have asked theta to be in degrees, so we need to figure this out. So C equals 3 minus 4i. This is the angle of interest. So tan theta is negative 4 over 3. And that means we have to use technology because it's not a common arc. And so this angle is tan inverse of negative 4/3, which is minus 53.3. But the theta is the same thing, okay, at 360 degrees. So let's add 360 because we want it to be in a positive 0 to 2 pi or 0 to 360 degrees. So we got this one to be minus 53.13, and theta is 360 at 362, 306.87. Now we want to find R, which is square root of x squared plus y squared, which means 3 squared plus negative 4 squared. So this one class is really negative 4 squared. It will give you the same answer as you know, which is 16. So 9 plus 16, which is 25, comes out as 5. So z, which is x plus yi, is r cis theta, and r cis theta would be 5 cosine of 306.87 plus I sine of 306.87 degrees. All right, we want to raise this to the power of 6. Again, if you want to do it just the way it is, we have to multiply by itself 6 times. So we better go with the polar form or complex form of a plus bi. So we find the r, which is 2 squared. So this number, 2 plus 2i. 2 squared plus 2 squared. And as you know, this is 4 and 4, 8, square root of 8, or 2 square root of 2. And I want to make sure we understand what we are looking at here. We are looking at just 2 plus 2i. And now we want to calculate theta, which is tan inverse, okay, tan of y over x. Tan theta is y over x, or 2 over 2. So theta is tan inverse of 2 over 2, or 1. And as you know, the answer is pi over 4. Again, I want to make sure that we understand this class. This means theta is tan inverse of y over x. So now we have a 2 plus 2i as r cis theta, 2 square root of 2 cosine of pi over 4 plus I sine pi over 4. Now we want to raise this to the power of 6. To raise this to the power of 6, we raise this one to the power of 6, according to this, and then we multiply the argument by 6. So when we raise this to the power of 6, this to the power of 6, as I mentioned, and then the argument times 6. So 3 pi over 2. And 2 square root of 2 to the power of 6. If you raise it to the power of 2, by the way, as you know, it's 8. Therefore, you need to cube 8. So 8 times itself 3 times, and you get 512, just in case to see how it's done. Now, as you know, cosine of 3 pi over 2 is 0. Sine is negative 1. So you have 512 times I times negative 1 gives you minus 512i as the final answer. So I hope you see that this is a lot faster than raising this to the power of 6, multiplying by itself 6 times. Z is 3 cosine of 130 degrees plus I sine of 130 degrees, and W is 4 cosine of 270 degrees plus I sine of 270 degrees. We want to find ZW using this formula, R1, R2, cis theta 1 plus theta 2. So therefore, the answer would be 3 times 4 times cosine of the sum of these two, 130 plus 270, plus I sine of 130 plus 270. This is 12. This is 400. And we can subtract 360. So if we subtract 360, we get 40. As you know, 40 and 400 are called coterminal. So I just subtracted 360 because it gives you the same angle, as you know. And since they ask for polar form, we are done. If they said that rectangular form or standard form, then we have to figure out what's cosine of 4D, what's sine of 4D using a calculator. We want to find the complex cube root of negative 1 plus square root of 3i. Again, we are using the same complex root concept that was explained. In this case, n is 3, and in general, k from 0 to n minus 1, that means 0, 1, 2 for us. So first, let's figure out what's r, which is x squared minus 1 quantity squared plus y squared or square root of 3 squared. And as you know, this is 1. This is 3. They add up to 4. Let me write that. This is 1, 3, 4, and it gives you 2. Now, as I mentioned, tan inverse of y over x. Theta is tan inverse of y over x, which means tan inverse of square root of 3 over -1, as you know, minus the square root of 3. And that is a common arc, so it's negative 60 degrees. Because remember, tan of 60 degrees is square root of 3, tan of negative 60 degrees is negative square root of 3, so minus 60 degrees. However, the reason it's 120 degrees, because remember, tangent is negative in the fourth quadrant and the second quadrant. And the reason we are looking for the second quadrant, because let's go back to this one. This says the x is negative, the y is positive. So this gives us second quadrant. Maybe you want to write next to it. So you see y, we go to 120 degrees instead of minus 60. So r cis theta is 2 cosine of 120 degrees plus I sine of 120 degrees. Again, as I said, it's easier to deal with degrees. Therefore, if we want the cube root, we want the cube root of this number. Okay, we want the cube root of this number. And then cosine of this divided by 3 plus 360. Remember, instead of 2 pi, we're going to write 360k divided by 3. Again, n is 3 because it says cube. Let me just write at top of that. This means the third root. So we write it in this form. So we are using this formula, cube root of 2, cosine of 120 degree divided by 3, 360k divided by 3. This is obviously 60. My apologies, 40. And this one is 120. So cosine of 40 degrees plus 120k, same thing for the sine. And k can be only 0, 1, 2. Notice, first let's plug in 0. If we plug in 0, this goes away, so we have only 40 degrees. Let's plug in 1. 1 makes this 120, and 40, it's 160 degrees. Let's plug in 2. 2 times 120, 240. With 40, 280. So those are the 3 roots. Again, I want to quickly show you the graph on that. So we came up with z sub 0 is cube root of 2 cosine of 40 plus I sine 40 all the way to the end. So if you draw a circle with radius cube root of 2, which is 1 point something, and then starting with 40 degrees, and then add 120 and add 120. So this is what you get. If you put those, here's the graph. So x squared plus y squared is cube root of 2 quantity squared. That means the radius is simply cube root of 2. Start with 40 degrees. That's the first one. And you add 120 degrees. That gives you the second one. You add another 120 degrees, and it gives you the third root. And as you can see, it has to start from somewhere. That's what we need to figure out. And it starts with 0 if it happened to be a positive number. For example, if it's 5, 7, any positive number starts with 0 degree and 120 degrees on each side. Otherwise, you have to figure out. The key is to figure out really the first one. And if it's any other root, for example, the fourth root, the key is to figure out the first one and then 360 degrees divided by 4, which is 90 degrees. Keep on adding 90 degrees. That's how it works.